Hello students, in today's lecture we will be discussing what kind of molecular orbitals will be formed by combination of two d orbitals, because we know that there are 5d orbitals. Some of them lie on the axis and some lie in between axis. Okay, so let's find out, okay, what will be the molecular orbitals formed by combination of d orbitals. Now over here it is worthwhile to mention that the internuclear axis out here is the z axis. Okay, so let us draw the z axis, and for that I am using this arrow. And now if I draw the d orbitals over here, so if I am drawing along the axis, if at all I am drawing along the axis like this, and we know the dz square orbital actually lies on the z axis, and it has two lobes with a donut around the nucleus. Okay, so there is a nucleus over here. Similarly, we can imagine another dz square orbital which also has a donut around the nucleus. Now charge wise, remember this, if it is positive, then this circular donut is the negative part. Okay, so if these dz square orbitals are combining, so they can combine again in the plus means bonding fashion, or in the minus anti-bonding fashion, and that will lead to the formation of sigma star molecular orbitals. Okay, so dz square, when they combine, they form sigma or sigma star orbitals. Now question is, what about the rest? So if you were to take other d orbitals, such as, now you have to understand that this one that I'm drawing, that is basically over here like this. Okay, and another one is combining with it, so it has the lobe like that. Okay, I have got the drawing almost as I want it to be. Well, let's do one thing. Okay, let's select this one and paste it. That would be easier to get two similar type of shapes. Okay, now we have exactly two similar type of orbitals combining. And if I'm calling this to be as dxy, okay, I'm calling this to be as dxy, and this one also I'm calling to be as dxy. Alright, so now if these two they combine, okay, so it is almost like you have a platel, okay. Don't think this is side on overlap, okay. This is like a flower, okay, and on top of that flower you're placing this flower, okay. So this type of combination, one d orbital sitting on the top of another d orbital, this we are going to call as to be leading to the formation of delta MOs, okay. So because the combination can be positive and negative, so we can say that there will be delta and delta star MOs, where the delta star MOs will be of higher energy. Again, similarly, if we were to combine over here the let's think of another orbital which we are saying as dx square dy square, okay, something like that. And this is something that will be lying along the axis. So if this is your z axis, just think this will be your x axis and that is your y axis. So that is how we have kept our three coordinate axis, okay. And here if you check on the top one, the lobes are basically lying in between the axis, okay. So this is your x and this is your y, and that is why it is called as dxy, okay. So what we are going to do, again just like before, we are going to copy this orbital, and so that we can generate a exact orbital like the previous one, and then we are thinking these two are combining. Obviously the nucleus over here is this one and that one, okay. For the previous one also I should mention the nucleus. Now if these two are again combining, we can again think like just like the before one, okay. In case of dxy, as if like one flower is sitting on the top of another flower, okay. Like the petals of the flower you're placing just exactly on top of it, like superimposing them, okay. So then again over here we can think of plus and minus combination for bonding and anti-bonding, and this will also lead to the formation of delta MO bonding and anti-bonding. Now what about dxz and dyz? Let's think about that. So suppose this is our internuclear axis again, and I'm thinking in my mind I have to draw dyz. So dyz will be what? Something that will be within the y and the z axis, right? So if this is my y and this is my z axis, right? So I'm drawing a lobe like that, and another lobe like that, okay, something like that. And this is my x-axis, okay. So this being the case, again we have to copy the orbital, okay, so that we can generate an exact copy. So again copied, we paste it over here, arrange it just like before, okay, and let me just mark these arrows with different color just to make some more sense. All right, x and y, x and y. So we are calling this as d y z, d y z. Now here, as you can see, the overlap is basically side on. If this is positive, positive, this is negative, negative, positive, positive, negative, negative. So here the overlaps can be positive or negative, and this kind of combination, which is a side on type of overlap, this is side on. The top one was head on, that's why it led to formation of sigma orbitals, okay, and the superimposing ones, okay, superimposed ones, they led to the formation of delta orbitals. All right. So here again, by the combination of bonding and antibonding, we will have pi and pi star MOs. And the last one, which is it? It is XZ. So for that, let's again draw one arrow. We keep the, in our mind, we have to draw a orbital that will lie in between the z-axis and the x-axis. So if this is the x-axis, all right. So again, what we will do, we will draw another lobe, which is suppose something like that. Hold on. Something like that. Okay. Again, we will say this is minus, this is plus, plus, minus, minus, right? This is the y-axis. Okay, let's copy this one. Paste it. And we have the other orbital over here. Okay, so this is our dxz, that is also dxz. Again, the overlap over here is of the side-on type, and that will lead to formation of pi and pi star orbitals, or molecular orbitals, as we were saying. So now it is clear to us that which orbitals will undergo side-on, which will be superimposing with each other, and which will be undergoing head-on overlap. That explains the entire story of the combination of d orbitals leading to the formation of molecular orbitals. Keep visiting Sarvasya classes. Thanks for listening. Have a great day.